Hi design technology students, today we are going to be looking at the construction of this Bluetooth speaker kit. We're going to learn a little bit about identifying different electronic components. We're going to learn the basics of soldering, and by the end of this video we'll be confident to put this kit together. The kit doesn't have a lot of instructions, but you will have the completed kit in front of you. The design aspect of this project is to actually design a case to house this. Now, it does come with its own case, but we're going to get creative and innovative with that whole design. Let's get over to the test bench, and I'm going to show you a little bit of the equipment that you'll be using, and then we'll get on with the different aspects of the construction of this kit. The first thing you need to know about soldering is that we need to be as tidy as possible and organized. Otherwise, things will not go well. Okay, let's unbag the kit and have a look at what we've got in here. And you probably want to make sure that you put everything in a bowl or in a container so that you're not going to lose parts. I am very practiced at not losing them. Okay, so lots of tiny little parts in here. Don't get too frightened. It looks more complex than it actually is. Now, this is the circuit board that you are going to be using. I've already put some parts in there, so we'll pop these out. As you can see, you'll sometimes see this referred to as a printed circuit board, PCB, if you use the acronym, and it's screen printed on the front with the parts and the orientation of the parts, because some of these parts are what's known as polarized, and they need to go in the right way. So as we progress with the soldering of this board, we will discuss which components you need to make sure you get in the right way and which ones you put in first. And as you can see on the back, they're the pads that you're going to solder to, and you can see little tracks, and they're the electrical connections between all the components that will make the circuit happen. Now, we've also got a parts list, which quite luckily tells us the value of the part, and on the back you have a schematic diagram. Now, the Bluetooth module itself is fully constructed, so you will not have to put any parts on this board. And you might notice that there's some tiny little integrated circuits in there that are what's known as SMD, surface mount devices. So this is an integrated circuit that's old school, that's a through-hole dual inline package, and just take a look at the little integrated circuits that are inside this thing. They're much smaller, and that's part and parcel of why electronics is so small these days. Now, these are the speakers. It's a stereo speaker, Bluetooth speaker, hence we have two of them. Now, be very careful when you take these out of the packet, because they have a magnetic ring on them. You will find that quite often parts will either be stuck to the magnet, or they may even be sneaking inside these speakers. So just make sure that all the parts are collected before you put these aside. These will probably be wired in very late in the process, so we're going to put them aside. I've also taken all the hardware, all the screws and the spacers and the nuts and bolts and everything else, and the perspex panels. Miss or your teacher may decide that you are going to incorporate these into your design, or may decide that you are not allowed to use these. So at any rate, while we're constructing, we can put these aside. And these are all the parts that are going to go into our board to hopefully complete this printed circuit board. Now, what this actual circuit does is, it says in Chinese here, this device, no, I can't read Chinese. What happens is, you've got a microphone, it will pick up the sound from the speaker, and you'll have dancing lights here. So this circuit's just designed to create a dancing, flashing light type display. We're going to identify some of our parts. These are our connecting wires, and you will see that these will actually plug into this Bluetooth module and be soldered into this circuit board. So that's what's going to happen with those. This is a switch. This will switch the unit on and off. This little thing that looks like a bug is actually a dual inline package integrated circuit, and it is the main part of the circuit, and it will have hundreds, if not thousands, if not tens of thousands of transistors hidden inside it. This is the microphone. While we're on the subject of parts, I should actually, it's very remiss of me not to mention this. Some of these parts have to go in the correct way. So when we start constructing the integrated circuit, the microphone that's going to pick up the actual sound for the dancing lights has to go in a particular way, and we will discuss that down the track. Another polarized component, polarized means it needs to go in the correct way, is our light emitting diode. This is a device that allows current to flow one way and produces a bright light. And you will notice that the legs on this, one is long and one is shorter. And the longer leg is the positive leg. So think longer, positive. This lovely little device here is what started the whole solid state electronics revolution, and it's called a transistor. And you'll notice the top of it has a certain shape. It's curved on the front and flat on the back. And if you look at the actual printed circuit board, you will see it's actually telling you the arrangement of and how to put this into the board. So you shouldn't have a problem getting that in the right way. Now, another device that's polarized is this thing here. It's called an electrolytic capacitor. I'm not going to go through how all these function because that would make the video very, very long. But if you want to find out, come and see me, and I'm happy to give you an explanation or do another video if people are really interested. Now, you will notice that this has a stripe on the side that says negative. So you can see the negative stripe. You can also see one leg is longer, just like the light emitting diode. So you can look for the longer leg, or if you've cut the legs already, look for the negative stripe. That's the negative lead. Now we have a little what's known as a trim pot, and the trim pot is just a variable resistor that you can adjust the value of. And finally, we've got lots and lots of these things here, and these are called resistors. Now they have a color code on them and a value that's written on the board. It tells you which resistor, R2, R1, etc., etc. And then you can find out what the actual value is off this little piece of paper. Now, you could read the little colored stripes on here. There's a color coding system to tell you what the value is, but we are going to cheat. It's just so much easier to grab a multimeter and check for the values, and I'll be showing you that in the video as well, how to do that so that we get the right resistors in the right spot in the circuit. Let's have a look at some of the soldering equipment you'll need. Okay, soldering equipment. This is a temperature controlled iron. It actually has a little display here for temperature. I keep it in the high end of the green arc, but I will put on the actual screen what temperature you need if you've got an iron that actually has a digital read of the actual temperature that you're going to be soldering at. You may be using an iron that's not temperature controlled, something like this that plugs in. Now, the main thing to remember when using this device is the tip, when it's switched on, is very, very hot. It will burn you. But if you hold onto the iron where you are supposed to, which is obviously on this insulated handle, everything will be okay. You do not want to be holding it like a pencil. That would be very, very bad. The other safety issue that needs to be taken into consideration is probably best to wear safety goggles in case some of the hot solder flicks into your eyes, and well ventilated space because you will be generating some smoke. You will see that shortly. Some of the basic tools. You will need some solder. You don't necessarily need this, but if you make a mistake, this is called solder wick or braid, and it is just like a copper braid, like knitted copper wire with some flux in it, and you can sit that over a component that you want to take out to desolder. So if you put a component in the wrong way, this will get you out of trouble. I probably won't do a demonstration of this, but you will have access to this, and I will help you out if that's necessary. And this is the side cutters for cutting off excess lead. And these are long nose pliers, and you can bend component leads with these and do various other things. So they're the basic tools that you're going to require to construct this kit. So the normal process for building a kit is you usually start with your resistors. Now the resistors are nice and low on the board. So the whole idea is, if you were looking at the board from the side, components that sit nice and flat on the board will go in first. And as you can see, our resistor is nice and flat. And then quite often, you'll go for other components that, even though these electrolytic capacitors are quite tall, they're not active components. By active, I mean things like integrated circuits, light emitting diodes, all the semiconductors. They normally go in last. So just follow my lead. We have 4 resistors, and we're going to put all 4 of these in the board. Now, they all have different values. So if you look at the top of this printed circuit board, or PCB, you can see each resistor is labeled R1, R2, etc., etc. So we just need to make sure that we actually select the right resistor for the right place. R1 is a 20k resistor. So I know that I'm looking for something with red as its first band, and I am guessing that it's probably that one, but you won't have to guess. You've only got 4 resistors to actually check. So I'm going to turn on my multimeter, and yours may be a bit different to this one, but they're all very, very similar. We put it over to the ohms range, and your teacher will help you set this up. And this is an auto ranging meter. So if I get the 2 leads, and we don't really care which way around these are going to go onto this resistor, we put one at one end and we just squeeze it up against the probe, and the other end we're going to go like that, and we're going to look at what value we get. 19 point, I'm not touching it, 19.97 kilo ohm. So that's the 20 kilo ohm resistor. And like I said, looking at this piece of paper, R1 is a 20 kilo ohm. And believe it or not only does it say it on the piece of paper, it's actually on the PCB as well, the printed circuit board. So what I do now is I bend these leads down so that they're going to squeeze through the holes that line up with 20 kilo ohms. So over here, R1 goes through that hole and that hole on the board. It says 20 kilo ohms, and I'm going to squeeze that down so that it sits in the board. And you want it to be sitting nice and flush with the surface, in other words, touching the surface. I squeeze it with my finger, flip the board over, and I push these leads at about a 45-degree angle from the board. The reason why I do that is it just stops it from falling out while I'm soldering it. So 45-degree angle, make sure you've got the 20K where R1 is, and now we are going to solder. It is not a highly technical skill. If you've got the right temperature set on the iron, you should be fine. Now, I'm going to get a little bit of solder. It's a bit cumbersome carrying this giant wheel of solder, so I'll just twist that around and around and around. Solder, 60% tin, 40% lead, and it's got a little bit of flux in the middle of it. Now, flux just helps the solder flow, so I'm just going to wrap that so that it's the excess is wound up, and I'm ready to solder. I'm going to grab my iron. Just going to get this meter out of the way. And it's always a good idea. You can see the tip at the moment of this iron is very, very dark and oxidized. Now, if I give it a nice little scrape on this, you usually have a damp sponge, but you'll see that if I do that and apply a little bit of solder, you can see now on the tip of that iron, you've got a bit of solder. Wipe the excess off. And what you do is you place the tip of the iron on the actual pad that you want to solder, and also touching the lead if possible. So you're heating up the lead and the pad. And then you hit it with a bit of solder. You don't want too much. And then I'm going to swing this around so I can get a better run at it. It sometimes helps to move the board around to get it the position you need. heat the pad and the lead, hit it with a bit of solder, and Bob's your uncle. Now, I think I've been a little bit light on this lead here, so you can always go back and apply a little bit more solder. You don't want to apply too much. Okay, so that is the first component soldered into the board. And we've got these leads here. Now, they're annoying, aren't they? So what I'm going to do is I'm going to get my side cutters, and I'm going to just above where the solder ends, snip them off. Snip off the excess. And that is how your finished soldered joint looks. So one component in, several more to go. A quick little tip. We don't want biggy blobby soldering like this. We really want, if you're looking at the shape of your solder, it really wants to look kind of like that. Now, don't panic if it's not exactly like this, but you don't want solder spilling out off the lead, okay? So just, don't overdo it. Back to the video. Let's do R2 now. Now, R2 is supposed to be 1.5 mega ohms. So it's going to start with a brown, and I think the yellow one here. So we'll grab our meter again, because we don't want to get that wrong. That would be an absolute catastrophe. I'm holding one end of the lead up against the probe. I try not to touch the other lead, because that could affect the resistance value, although for these values it probably doesn't make a huge difference. But holding one end up against the probe, you can even set it down on the table. That's giving me a 1.491 mega ohms. So lo and behold, yes, that is the correct value, 1.5 mega ohms. Now, you might be saying, why aren't they exactly what they're supposed to be? Well, all resistors, and more often than not, electronic components have a tolerance. So they're not exactly the value that you want, unless you buy very, very high tolerance components, which you can buy, but they're very, very expensive. So you can see there that I've looked for 1.5 mega ohms R2 on the printed circuit board. And where the picture tells me to put it, that's where I've put it. I've bent my leads. Now I squeeze it through the board till it hits the bottom. And now you can see those leads are crossed over like that. We don't want them to stay like that. We bend them at 45 degrees. And then we're ready to solder. And like I said, generates quite a bit of smoke. So you want to make sure that you're doing this in a well-ventilated area. Now, I don't know if you can hear the fan behind me, but I've got a fan going, so it blows the smoke away from my face. You can buy lead-free solder. I find that it doesn't work and flow as well as this stuff that has the lead in it. So you may have lead-free solder at school, but it's not dangerous to use lead solder as long as you are in a well-ventilated area and you're not breathing it in. Okay, so once again, we've snipped those leads. Do not apply too much solder. You don't need a heap of solder. R3 is a 10K, so we were looking at a brown is a number 1, so it's going to start with brown. We know that. That's 11K, 10K, 10.04. So R3, 10K. Resistors, the way they go in doesn't really matter. Some people put them in so that the stripes read in the same direction, left to right. We don't need to worry about that. As long as the right value is in the right position, it will not make a difference. Flush with the board again, 45-degree angle. And you just want to make sure that you heat the pad up and the lead as well. The solder will flow onto the lead and the pad, and that's done. lead and pad. Now, if the tip of your soldering iron is looking like it needs a bit of a clean, just give it a quick wipe. Excess lead comes off, and we know the final value, which is R4, needs to go into the board, and R4 is a 470 ohm resistor, black, brown, black is 0, brown, red, orange, so it should be 470 will be orange, yellow, so it'll start with yellow, and then purple, 470. Now, what I'm going to do is I'm going to put in one of the electrolytic capacitors, the big one. I'm going to pull all the electrolytics aside so you can see what an electrolytic capacitor looks like, because they come in all different sizes depending on their value. The higher the value, usually the larger the capacitor. So there you've got 4 of those. And if we look at our little instruction sheet here, you've got 1, 2, 3. Interesting. Now it actually says there's 2 of these larger capacitors, and they're actually, that's just the meter switching off. They're actually designed to change the bass effect of the speakers. So we're not going to worry about that for the time being. I might talk about that later. Let's not worry about that. These are the ones that go into the actual board. So we have a 2.2 microfarad, a 1 microfarad, and 100. So let's find that 100 microfarad, and it says it on the side here. So this green one in this case is the 100 microfarad, but you can see on the side of the actual case, if you read the writing, it says 100 microfarad, and it's a 16 volt voltage rating. So 100 microfarad is actually C1. So we look on the board here, and we're looking for the C1 capacitor, which is this one here, labeled C1. And then we're looking for the longer lead, and the longer lead goes on the side of the circle that hasn't got the stripes on it, that says positive. And the other lead, which is shorter and also has a negative stripe next to it, goes on the other side. Same deal, you push it through, you bend the leads at 45 degrees so the component stays where it should, and you solder it in. The actual iron's at about a 45-degree angle to the lead as well. Keeping in mind, this is not absolutely crucial. Don't get too precious about how you do this. As long as you've got enough solder on the lead and you've made a good joint, it shouldn't be a problem. Now, every now and then, I'm going to do an inspection on this and say, hey, I need to add stuff to this. Now, Mr. Komenos is blind, so he uses these goggles to inspect the board. And I can already see that I haven't quite covered the actual pad on the printed circuit board, so I'm going to just add a little bit more. Sometimes you might have to up the heat on your iron. If you're actually soldering a larger pad or a larger component, the actual component might suck the heat away, heat sink, so you would actually have to up the power. But on this board, we should be able to leave it as it is. C2, which is a 2.2 microfarad. So let's look for the 2.2. This has 2.2 microfarads written on the side of it. So I'm going to pop that in. Once again, polarized, so make sure you get it right the first time. Long lead goes to the side that says positive. Short lead with the stripe on the side of the can goes to the stripy half. And push it through so it's nice and flat on the board. Bend the leads at 45 degrees. Pick up your solder and solder your part in. Snip, snip, Okay, one or more capacitor to go. And it should be a 1 microfarad. Let's make sure that it is. Yep, it's 1 microfarad. Long lead to the positive, short lead to the negative. Pop it through. Make sure that it's flat with the surface. Once again, if the components aren't perfectly flat with the surface, it's not the end of the world. It will still work, but it's nice to get it right the first time. Heat the pad up and the lead. Touch the lead and the tip of the soldering iron. Wait, and take the iron away. So on the other side, that's all your capacitors in. The only other non-active component, passive component that needs to go in is this variable little potentiometer that you can change the value of. Okay, so that just gets popped in. The leads on this have a little kink in them, so you don't need to really bend them. You just need to make sure that they're coming through on the other side. You cannot put this in the wrong way because of the way the leads are set up. Pop it in the board the way it fits and solder it in. Now, a little word on the installation of the diodes. If you were building this kit for real and using the case it comes with, you would need to put the actual LEDs, which are these things that produce the light, such that they would fit through the front panel, so you would actually see them sticking through the front panel. But because you're going to build your own case, that's probably not the case. But if you did want them to stick through the front, what you would need to do is you would need to have them sitting in the board. Now, these components, once again, are polarized. You can see on the actual screen print a plus and a minus. Long lead goes into the plus, just like the electrolytic capacitor. But if you wanted to have these such that they appear sticking out the front panel, you would actually have to have them in the board, and you would actually have to have them sticking out the front. So you need to bend your leads so that they were placed in the board just, I'm trying to see the screen here, just like that, so that they would actually face forwards. And I am not going to do that because we've already had a discussion about this, your teacher and I, and we've decided that you can probably make the front of your actual design of the case such that you can see these LEDs through a clear panel, and it can be really nice and funky because you can actually see the electronics inside as well. Or you can just dispense with this dancing light display altogether. But that would be a real shame because Bluetooth speaker, this just adds a nice extra dimension. So we're going to put in all of these LEDs. I'm going to show you one. I'm going to have them flush with the board. But like I said, you could even mount them in your case and run a little piece of wire from the LED down to the board. Okay, so you could put these somewhere else if you wanted and put the board elsewhere. And you could run quite long leads to these without causing any issues whatsoever. So that is the wonderful thing about being able to solder. You've got that option, okay? So I'm going to put in the board, and like I always do, 45-degree angle. I've made sure I've got it in the right way. And then I'm just going to solder it in. I will come back when I have all of those LEDs in, and I will show you how to put in the last few components, which are a little bit more tricky. When I say a little bit more tricky, just getting them into the actual board might be difficult. But see you in a few minutes. All the LEDs are now in position, and I'm going to now show you how to put the transistor in. Now, if you look at the top of the transistor, it has a curved front, and you basically look at the actual printed circuit board and you put it in so that the picture matches the shape of the top of the transistor. Push it as far as you can go in. Now, you're not going to get it flush with the actual circuit board. Don't force it in because you're going to damage it. Just push it down so that you can get it down as far as it'll go without being brutal with it. And just bend the leads 45. I usually bend the two outside leads at 45 degrees. And then the one in the middle, which in this case is labeled the base, which is where the signal actually goes into the transistor, I bend it 45 degrees either to the front or the back. It doesn't really matter. It's just a way of making sure that they're not going to interfere with each other when you solder them. And we're going to solder that part in. And like I said, it's a polarized component, so you need to get it in the correct way, just like the LEDs and the electrolytic capacitors. I know I keep harping on about it, but it's very easy to put them in the wrong way. Now, if you realize before you apply power to the circuit, which you'll always check before you power up, we can usually get it out, so don't panic. Okay, so that's the actual transistor. The microphone, I'm going to just grab a piece of paper and I'm going to show you what you need to be looking for with that, because it's not labeled very well. Okay, just in case we didn't get it, the top of the transistor is shaped like that, with the 3 leads coming out of it. And so if you look at the printed circuit board, you've got a shape like that with 3 little holes. So obviously when you sit your transistor down, it's going to sit, so the curved front of the transistor is matching the curve on the printed circuit board. Okay, now with the microphone, if you actually grab this microphone and have a really close look at it, you will see that you've got, this is looking at the bottom of it, you've got 2 leads coming out of it. But one of those leads, if you look really, really carefully, you can see little tracks heading off to the outside case, okay? That is the earth, okay? So that is the negative lead. So if you can find the little pad where the actual leads, where these little tracks are heading to the outside, that's going to be the negative. And this one then obviously is the positive lead. So that is how you're going to know what way to put it in. Now, I've just said that I've recognized that this lead here is the negative. And then if you look at the actual printed circuit board, I know that that's the negative. So make sure when I flip it, I've got my finger on it so I know which one's negative. Negative is at the bottom here on the side that's closest to the edge. And then the positive is the other one. And then we just pop it in. We get, this one can go flush with the board. And we bend our leads at 45 degrees. Make sure before you solder that it hasn't slipped out. You don't want it sort of dangling off the board. And we are going to solder that in position. Okay. Now, on the top of the board here, you've got 2 what looks like jumper leads. That usually means you need to short that part of the board out to get it to work. Now, it's written in Chinese. So what I am probably going to do is I am going to leave the jumpers out and see if it works. And if it doesn't work, I'm going to pop them in. So we will do that last. Okay, now this integrated circuit, which is the brains of the operation, it needs to go in a certain way. And if you look at the top of the case, and I'll just do another little picture here, because a picture tells 1,000 words, so they say. If you look at the top of this case, you will see that it has a little dimple in the top. That is the first thing you need to look for, because on your printed circuit board, I'll swing it around the same direction, you can see there is a little dimple just here in the actual screen print on the printed circuit board. And what that tells you is that that's the top of the actual integrated circuit. And then the leads coming out the side, I think there's 8 of them. 1, 2, 3, 4, 5, 6, 7. Yep, 8. So it's a 16-pin integrated circuit. Now, you don't really need to know this. If you put this in the board this correct way around, you usually look for the U at the top, and you look for the tiny little circle on one of the pins, because that's pin number 1. Now, this also has a little dot here. Ignore that. We don't need to worry about that. So that is pin 1, top left-hand corner looking from above. And then as you go in this direction, you're going to go 2, 3, 4, 5, 6, 7, 8. And then the logical thing would be go 9, 10, but you don't. You actually go down and around, okay? So then we come back up the other side, 10, 11, 12, 13, 14, 15, 16. So that's how you can tell on the schematic which pin is which. You don't really need to know that. All you need to know is that on the actual printed circuit board, screen print, there's a little dimple at the top, and you need to make sure that your chip actually lines up. Now these legs may have been bent in transit, and so you might need to get a screwdriver, sit the actual chip on the bench and straighten out any bent leads, etc., etc. But if you're having trouble with that, don't force it. Ask your teacher for help, because it's imperative that this device survives and gets put in the right way. Another thing that would be prudent is to just, when you've got it in the actual board, before you solder it, just ask your teacher to have a quick look to make sure that you have it in the correct way. So I've popped it in the board. It should stay there. Make sure it's flush with the surface. Now you're going to flip it over, and what you normally do is you normally make sure that you solder opposite corners, and then make sure it's sitting flat in the board. So I'm going to solder this pin here, and this one here. And then I'm going to flip the board over, and I'm just going to make sure that my integrated circuit's sitting nice and flat and it hasn't popped out. So I'm happy with that now, and I'm happy that it's in the correct way. And so I'm going to now solder all the pins. Now the other thing is that because the pins are all very, very close together, you do not want to put too much solder on them. So I would normally go from the side here, and I'm going to put my goggles on so I can actually see what I'm doing. Now these are on the same pad or the same track, so you don't have to worry about that one bridging out. We're just going to make sure that none of these pins touch each other. Now back in the day when I was very good at this, I could just run the solder along and do them all in one go. But let's do them separately. Okay, so our integrated circuit is in the board. That is now most of the components. Now we need to get the power and the switch to work. Now the Bluetooth speaker is powered from a USB connection. The red is the positive and the black is the negative. So if we want this switch to operate as a switch, you would normally place the switch in the positive line of the circuit. And so what I'm going to do is I'm going to take this piece of wire here, and we're going to use it to install our switch. Now, depending on the case design, you would mount your switch wherever it's going on your case, and then you would think about how much wire you need. And you don't necessarily need to use this wire. Any wire will do to hook this up. We'll just get some hookup wire, which will be made available to you, and you'll be able to actually put your switch wherever it needs to go if this wire is not long enough. Let's twist this wire up. Now what I normally do with this type of wire is, because it's got strands, we do what's known as tinning the wire. And tinning the wire just means that the strands are not going to all go all fluffy and go where you don't want them to. So I normally set up my solder on the bench, and I heat the wire and the solder, and I just run. It'll get once it starts to melt, the solder will run onto the wire, and it'll just stick it all together. And I just slowly run it back, and that's just a way of making sure that your wire is not going to go all fluffy. And then I normally trim the ends as well, because I might not have got solder on the ends of them, and that'll make them easier to solder as well, because they have a bit of solder on them now. Now I'm going to stick this end in the switch. It's, once again, it doesn't matter which way around it goes, but I'm going to go from the inside and bend the wire down, sit it on the bench, make sure that it's up as far as it'll go, switch up, And this is quite a large surface, so sometimes it might be harder to solder. Now, you probably notice I was very clumsy there, and I've actually melted the corner of that switch, and it didn't solder properly. So, not a good start. Never mind. Let's try again. So once again, look at the angle you're soldering at. If the soldering iron is going to touch something, it's going to melt. Move the iron away from that thing, and it means you're just not going to destroy all your parts. This will take a bit more solder because it's a larger. Now the other thing is too, on a larger joint like that, don't move it for a little while. Let it cool down so that it's not going to fall out. And so that's that first wire in. Now you've got a bit of excess wire there that you can trim off. And then let's get the other wire in. Now, even though these are black and red, I'm going to sit this switch. It's a normal practice to put the switch in the active line or the positive line, so that that's where you break the circuit. So that's what I'm going to do. So I'll show you how I'm going to wire this up in just a second. But I'm just putting black on one side, red on the other. Plenty of solder. Let it cool down and nip off the excess. So that's the switch, that end of the switch. Now I'm going to peel back these wires at this end. And what we need to do is, I'm going to join this red wire to this black wire. And you can use a bit of tape to seal this up so that they don't short out. If I push too hard on these cutters, I'm going to cut the wire. But if I just gently squeeze them together, I can usually strip the wire without losing the actual wire that's inside, so stripping the insulation out. There is a tool called a wire stripper. I don't own one, and I've always just stripped wires like that. I'm going to, once again, tin these wires. Tin these wires. And then I'm going to go, I haven't tinned these because I think they're already tinned, and I have to get them through the holes in the board. And so we don't want to make them any thicker than they are because the holes look quite narrow. Okay, so what I'm going to do now is I'm going to put the black wire in the part of the PCB that says ground. I'm going to just push the wire over a little bit so it's going to stay in there, because we don't want it to fall out while we're soldering it. So that's the black wire from our USB connector. Now we need to say, what are we going to do now? And that is, we're going to take the positive, and we're going to, it doesn't really matter which way around this goes now. I'm going to connect red to, I'm going to connect the black lead to the red lead here, only because I want the red lead to go into the printed circuit board, because it'll just make more sense to see a red wire going where it says VCC, which is the positive terminal. And what I'm doing here is I'm just twisting that tinned wire around and around and around so that it's nicely connected. And then I'm going to apply a little bit of solder to it. And then, just so it doesn't short out with other things on the board, etc., etc., I'm going to grab a little bit of this electrical tape just to insulate the whole show so that we don't have it shorting out and causing problems in the circuit. Now, do we need to worry about these voltages on this circuit coming out of the USB connector on our computer? No, we don't need to worry because it's only 5 volts DC, but we could cause problems with our computer if we don't do this properly. So there you have it. I've just put a little bit of insulating tape on there so that even if it's flopping around, it's not going to touch anything it shouldn't. Now, the lead that I've got left, which I've tinned, I'm just going to trim it back a little bit because it was a little bit fluffy on the ends. And in the actual board here, where it says VCC, and you'll be able to see this circuit in class because you'll have it in front of you. I'm going to slide that wire into the board, bend the wire back like I normally do to hold it in there. And sometimes if things are flopping around and won't stay on the deck like you want them to, you can just pop something on top like that to make life easy for yourself. And then we're just going to solder that in. And the excess, I think, is touching another part of the circuit. So let's snip that off. So now we have power to the circuit, and we have a switch to switch it on and off if we plug it into USB. And all the components are in place. Now, believe it or not, this needs to be connected to the Bluetooth speaker, but it is a standalone circuit and it should be able to hear any noise I'm making, and these LEDs should flash if I plug it into a power supply, if it's all assembled like it should be, and if I don't need these jumper leads. So let's throw caution to the wind. I will quickly do an inspection, and you should do an inspection too, just to make sure that all your components are in the right place and everything looks good. It always pays to actually check all of these components. And if you want to be doubly careful, quite often you'll have a dead short across the power, and that's always going to be a problem. So let's put it on ohms and just measure from positive to negative. Now we shouldn't see a dead short there. And we're seeing 3.9 kilo ohms, so that's good. So we haven't got any dead shorts. That's always something you can check for quite easily. Let's plug this in and see if it works. I'm fascinated to see where we managed to get this to work. We've got to switch it on. Hey, might have actually got it to work. Now these links, what you can do is, you can just, I've unplugged it now, you can just use some of the off-cut leads that you've got from when you were putting your resistors in. So hold on to them, and you can use those to create a link, which is just a piece of wire that runs from one hole to the other. Now, I don't even know what these actually do, so I'm going to pop them in, and if I'm unhappy with how the circuit behaves, hopefully it doesn't blow things up, we can just cut them. We don't even have to desolder them, we just cut the link from the top of the board with the side cutters. I'm going to pop them both in and solder them in position, and I'll get back to you and we'll see what it does. Okay, so desoldering. We get a nice clean piece of this wick, and all you need to do is find the component that you want to take out, and you just sit the braid over the top of the solder, put the iron on top, and you wait till you see it sucking the solder into the copper braid. And you do it on both leads. And hopefully the part comes out. With components that are what's known as plated through, it can be a lot harder. There you go. It's out already. So let's pop in another LED. So maybe they gave us extras because they know we actually had extras in the kit. They might know that there's some that don't work. So, hey, at least they're honest. Hello, hello, hello. Okay, so D6 is still hello, hello, hello. D6 is still mucking up. Hello, hello. 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 Yes, all the LEDs are working now. So they probably do give you extra LEDs because there's some duds. Anyway, that's the light chasing part of the circuit, all working. You will have that in class to have a look at, see how I've wired it all up. So that will be helpful, I'm hoping. Now we're just going to do the Bluetooth part of the circuit. And very, very quickly, what I'm going to explain to you is that this red connector here is the power, and we're going to steal the power. There's an extra port here to get the power from the USB running up to here, and then these two here are your speaker connections. So we're given 3 of these connectors, 1 for power and 2 for speakers. So let's wire that up. All you need to do is, and I'm going to show you how to do one of them, you need to wire your speaker to this piece of wire. You've got 2 little tabs there, and like I said, sometimes speakers actually have a positive and a negative on them. It depends on the type of speaker. I am assuming that these speakers are not polarized. They don't have anything indicating that they need a positive and a negative, so I'm going to put 1 lead in one side and 1 lead in the other side. And it could be helpful to strip these wires. You just have to be very, very careful stripping these wires. Now, we may decide that we want to try and get ourselves some decent wire strippers to make life easier. We shall see, but otherwise, there's bound to be someone in your class that's really, really good at stripping wires. Get them to help you. So these are solid, so you don't need to tin them. And I am going, they haven't got strands, so I'm going to push the wire through from behind and fold it over. And once I'm in position, grab my solder and just put a little bit of solder on the back of the speaker tab. Now the excess that's there, like you always do, you don't want it shorting out on the actual case. Take it off, and then this one here, once again, feed it through the back of the speaker. Fold it over so it doesn't fall out. I won't show you how to do the other one. Now, power. One of these needs to go from here into the red connector here. So you need to have the red with the red on your board here and the black with the black. So you've got 2 extra holes here, red to red, black to black, so they line up. Now I'm going to switch this off so we don't short this out while we're soldering. You should never solder while you've got power applied to the circuit for so many obvious reasons. Okay, so I'm going to put the power cord in next, and then I'm going to, won't show you doing this one, and then I'll show you how we wire it all together. And any excess wire that's going places it shouldn't, you've just got to make sure that it's removed. You don't want it shorting out things that it shouldn't. Okay, I'll be back in a second after I've done the other speaker. So power's plugged into the red one, and the 2 speakers are going to the other 2 plugs. Hopefully when we switch this on, it's going to all work. Now, spoiler alert, I have started this, and the first time I started it, it failed. And I thought, oh, something's blowing up. I'm pretty sure that it's drawing a little bit too much current for a standard USB, or it needs a type of USB. So I'm running it off a little USB plug pack. And let's just see if that's any better. Fingers crossed. Okay. And then we're going to look for it in the menu. Switch on Bluetooth. Connecting is okay. And we are connected. And let's find some music. Volume down, volume up, and switch off. Switch on. Bluetooth is started. Please connect. Connecting is okay. So hopefully you have a completed circuit that works. Don't lament if you haven't managed to get it to work. Come and see me after you've tried troubleshooting it yourself, and I'm sure that we can work out whatever problems you have and get your circuit operational. The fun begins now. You need to design an innovative enclosure, which will be a lot of fun. What's happened over the course of this video, which is about an hour long, is that hopefully you've learned a great skill, and that is of soldering, because soldering allows you, once you learn a little bit about how to read a schematic diagram and follow instructions, the sky's the limit when it comes to building stuff. Everything you see around you here is stuff that I've been able to build and prototype from schematics and ideas that I've found online, and some things that simple things that I've designed myself. Things like this, a Morse generator. Anyway, I shall not bore you with my nerdy stuff. Enjoy the rest of the project, and I might see you at school. Bye.